All right, in this example, these next two examples, we're going to be doing sum and difference identities dealing with sines and tangents. So sine has these two different formulas, so if you're adding angles or subtracting angles, and then tangent has a little bit more complicated formulas for adding and subtracting. So basically the goal every single time is the situation that you have here is you're trying to evaluate sine of 75 without a calculator, and we need two angles that either add or subtract to get to 75. Our choices are going to be from 30s, 60s, and 45s because those are the ones that we know the exact values of. So sine of 45 or sine of 75 is a combination of 30 and 45 added together. So I'm going to be breaking this up into, and you could do a lot of different combinations, but that's just kind of the one that comes to my head. So sine of 30 degrees plus 45 degrees, and so that means I'm going to be using the top formula. So sine of 30 times cosine 45 plus cosine of 30 times sine of 45. All right, so sine of 30 is 1/2, opposite over adjacent, 1/2. Cosine of 45 is adjacent over hypotenuse, so 1 over root 2, which really turns into root 2 over 2 if you rationalize. And then cosine of 30 is root 3 over 2. And then sine of 45 is opposite over hypotenuse, so 1 over root 2, which rationalizes to root 2 over 2. And then we have a root 2 over 4 plus a root 6 over 4 when you put the square roots together, which turns out to be root 2 plus root 6 over 4. And again, you can verify this stuff by plugging this into the calculator, plug this into the calculator, and they should turn out to be the exact same thing. So next example is tangent problem. Tangent of 7 pi over 12. So radians is a little more complicated. We got to figure out stuff that adds up to a 7 pi over 12. That is really going to simplify to things that are pi over 3s, pi over 6s, and pi over 4s, which are reference angles for these. So kind of start off with maybe a little trial and error, where you could start off with pi over 12 plus a 6 pi over 12 makes 7 pi over 12. That one simplifies great. That one can't simplify, so I can't make it into a pi over 3, pi over 6, or anything like that. So how about a 2 pi over 12 plus a 5 pi over 12. Well, 2 pi over 12 would be good, but the 5 pi over 12 will not. So how about a 3 pi over 12 plus a 4 pi over 12? Yes. So that can become pi over 4, and this can become a pi over 3. Perfect. So we're looking at doing tangent of pi over 4 plus pi over 3. All right, so we plug things right into the formula. We have an addition formula, so we're going to do tangent of pi over 4 plus tangent of pi over 3 divided by 1 minus those two same values. Okay, so tangent of pi over 4 is opposite over adjacent, so that's 1. Pi over 3, so that's a 60-degree reference angle, so you're looking at opposite over adjacent, so root 3. It's not bad. And then it's going to be 1 minus these same two numbers multiplied together, so 1 times root 3, which is going to give us a 1 plus root 3 over 1 minus root 3. All right, bad news. is most likely this is not an okay answer because you have a square root in the bottom. So we have to clean that up. We have to rationalize the denominator. Now it's not a wrong answer, it's just not a complete answer, so we need to clean it up. So we're going to multiply the bottom, if you remember, by its conjugate. So we got to distribute, we got to FOIL this out. The top works out to be whatever. We're not really concerned about the top, it's more the bottom that we're worried about. So the top is, let's see, a 1 times 1 is a 1. 1 times root 3 is a root 3, and then root 3 times 1 is root 3. Root 3 times root 3 is square root of 9, which is 3. So that's the top. The bottom, things are going to cancel unlike multiplying on the top. So 1 times 1 is 1. 1 times root 3 is root 3. And then negative 1, root 3 times 1 is a negative root 3, which those are going to cancel. And then negative root 3 times a root 3 is minus square root of 9, which is 3. So those will go away. And we are sitting with a 4 plus 2 root 3 on the top. And on the bottom we got a 1 minus 3 is a negative 2. So all of these are divisible and we'll apply the negative to everything. So our final answer is going to be a negative 2 minus root 3. And that is as simplified as we can get. So there is one other type of problem that you potentially will come across, and it is just a recognition thing and then an evaluate. So if you were sitting with sine of 40, cosine of 160 minus cosine cosine of 40 times sine of 160. So one of these is you're looking to go backwards. So we're looking at the minus formula, and we have these two angles. As long as those angles are the same, 40 and 40, and then 160 and 160, we'll pull it back to this. So you're really looking at sine of 40 minus 160. All right, so if you put that together, that's really going to be sine of a negative 120. I got to figure out what my reference angle is, the quadrant that we're in. So if we draw negative 120, we're going in this direction, and we are down here. That would be a negative 120. Reference angle we're looking at is a 60. So we're really doing sine of 60. So sine of 60 is root 3 over 2. And then this is where we use a smart trig class. We're in the third quadrant. Tangent is the only positive in that quadrant. So our answer is going to be a negative root 3 over 2. So you could really double check by plugging all that original into the calculator. Not this, just in case you made a mistake from here to here. Plug that all into the calculator and get some sort of a decimal. Plug that into the calculator and you should get the exact same decimal. All right, so that was a little bit of a sum and difference identities involving sines and tangents.